Alright, so we're starting a new unit, and this new unit's going to focus on rates, ratios, and percents, and then something called proportions, which compares the previous things. So we're going to start off just describing some of the basics, which is what is a ratio, because that's really what this unit is about, and then I'm going to tie in what is a rate with that. So a ratio is basically a way of describing the size of one group compared to another group. It could be multiple groups, but in most of our cases we're just going to be focusing on two. So if I was saying in this first example that there is a group that has one boy and three girls, we're just describing exactly that situation, that there is a group that is one boy and three girls, and that is a ratio. Okay, and there are several different ways that we can write ratios, and so you can see there's some other examples here that you might have seen before. We have what's called the kind of the colon representation of that, and that is that if I do, we read this as 1 to 3, right? If I say the ratio is 1 to 3, we're basically saying there's one boy for every three girls, right? We can also write this in something that is very common to you, which is a fraction, one boy to three girls, right? So these are all really reading as the same thing, and it's just different notations for different situations depending on what we're doing, okay? So up here in the learning goal, it also says we're going to understand what a rate is, okay? And so what a rate is basically a ratio where the labels that we're attaching to the numbers are different things. So we're measuring different things. And in this case, these are rates, right? One boy to three girls. Those are different labels that we're attaching to them, so that would be considered a rate. So common things that you might have seen that are ratios are like something like miles per hour. So we're comparing how many miles you're traveling to how many hours you're traveling. So those are different labels that we're attaching to it. So we're going to say that that would be a rate. Okay? So ratios and rates are really kind of the same thing, except rates is a very specific version in which we're using labels to describe them, and they happen to be different. Okay? So let's look at an example. Okay, so if I survey a class and I ask the class who's going on the senior trip, and 22 people say yes and 6 people say no, if I wanted to write a ratio of yes to no using each of these formats, here's what it would look like. I would say 22 yes to 6 no. So this is like the word representation of our ratio. I could also say 22 to 6, okay, which is again the colon representation, or I could do 22 over 6, right? And so in each of these cases, this is yes to no. So yes is first, no is second. So I know that as I read these, that obviously these ones have the labels, but the ones that don't have labels, yes to no, the fact that I wrote that they asked me to write yes first and no second lets me know that these are the yeses and these are the no's. Same thing, yes, no, because of the way they described it. If they changed this and said write the ratio of no to yes, I would actually change it so it would look like that, right? So the order that we write these things matters. When they describe it as yes to no, I always want yes to be first, or I want yes to be in the numerator, or yes to be first in my description. So these are, again, just different ways that we might write about the comparison between all of the people that said yes and all the people that said no when I gave this survey, okay? So we also have what are called equivalent ratios, right? And here's a good example of that. If I go back to this example, right, of surveying the class, well, I have a class of 28 people, right? 22 people said yes, 6 people said no, 28 people. But let's say that there are a lot more people in the senior class, the entire senior class, not just the 28 people that are sitting in front of me. And so what I can do is I can write an equivalent fraction, and I can say, well, if I can estimate that that's probably going to be how it breaks down, that for every 22 people that say yes, 6 people will say no, what I can do is then compare that and say, well, what happens if I have a group of like 1,000 people or 100 people? And I can break it down and kind of keep that equivalent ratio of every time 22 people say yes, 6 people will say no, and we can move that around. So let's look at an example without a word problem built around it, and then we'll expand and look at the word problems, okay? So, excuse me. Equivalent ratios are ratios where all of the numbers have a common factor that can be removed, or that we can like multiply it to increase the value. So it's very similar to fractions, because you remember right here we said ratios can be written as fractions, right? If I take my fraction example and I were to say something like 2/7, right? I can write 2/7 if I multiply by 2. well, this is the same as times 2 times 2, right, and get that. Or I could multiply these by 3 and say this is 6 and this is 21. These all represent the same fraction. They all mean 2/7, right? So I can do the same thing with ratios. If I take this 1 to 4 ratio, if I multiply this by 2 and this by 2, well, I'd get 2 to 8. Okay, if I multiply this by 3 and this by 3, I'd get 3 to 12. Okay, if I multiply this by 4 and this by 4, I'd get 4 to 16. Okay, so all of these ratios are equivalent to 1 to 4, because this one's saying, all right, here's kind of like what this means. We're going to say this is one thing, and then on the other side, I have 4 things. Okay, this is saying, all right, I have 2 things, and on the other side, I have 8 things. And I'm only going to do the next one. This one's saying I have 3 things. This one's saying I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so you can see as I'm increasing this by 1, I'm increasing this group by 4, right? So I have a group of 4 here, right? So I have like a group and a group. Here I had one group of 4. Here I have 2 groups of 4, and I don't know if I can break this one down. Let's see if I can do this, right? Here I have 3 groups of 4, right? So every single time I increase the left-hand side by 1, I increase the right-hand side by 4. So these are all equivalent ratios because they're keeping that connection between what we wrote on the left and what we wrote on the right the same, right? So they are equivalent ratios, right? So here's my my example, and this is specific to our school, right? So if we say the ratio of short days to long days at East is 4 short days to 2 long days, right? And someone said, you know what? I want to have 6 long days in a row. And we wanted to keep the same ratio of short days to long days. Here's how it would work, right? So I'm going to write this out. I'm going to say this saying, okay, 4 short, right? The ratio of short to long would be 4 short, okay, to 2 long, okay? And so, and actually I'm going to rewrite this. So this is not a nice way of writing it. So let's make it look a little nicer. So I'm actually going to write up here a label, and I'm going to call this short to long, okay? And then below that, I'm going to say I have 4 short days for every 2 long days, right? So that makes it look a little nicer. And so what I can say is they're telling me that they want there to be 6 long days. So 6 long days would go on the right. I want this to be a 6, right? And so it looks like I changed this by doing times 3. So what I'm going to do over here is I'm going to do the same thing. I'm going to say I want to keep the same ratio. So I want to multiply this by 3, and that's going to make this a 12, right? So if I say the ratio is 12 to 6, I would need 12 short days for us to have 6 long days, right? And that would keep the same ratio of short to long, right? I have twice as many short days as I do long days, right? So that's the idea of equivalent ratio is that as long as I increase one of them using multiplication, I can do the same thing with the other, and it will stay the same basic breakdown, okay? So a ratio of miles to gallons, okay, is 300 miles to 15 gallons. Okay, and let's say you're taking a trip and you're trying to go 900 miles. It's the same basic idea. I'm going to say my ratio is miles to gallons. Okay, and this one says 300 miles to 15 gallons. And they would like us to go 900 miles, right? So I'm going to say I want this to be 900 miles. Okay, and we're wondering what would the gallons have to be. Okay, so it looks like this is again a times 3. So I'm going to do a times 3 over here, and I'm going to end up with 45. So the answer to their question, how many gallons do you need to drive 900 miles? Well, we're using equivalent ratios to say that 900 miles would be 45 gallons. Okay. So the important thing here that I want to point out is that I'm using a lot of organization, because if I look at my next problem, in this problem they gave me miles, 900 miles. This one they're giving me gallons. So if I'm being organized and saying miles to gallons, okay, and again in the original problem that hasn't changed, 300 miles is 15 gallons. Okay, now they're giving me gallons. So when I'm plugging this in, you know, and I'm looking at the next line and saying, ooh, that did not work. Let's fix that. So I'm going to say I would really like there to be 150 gallons. I'm making sure that because I labeled at the top that it's on the correct side. This is a times 10. Okay, so that means on this side I'm going to do times 10, and I'm going to find that I can drive 3,000 miles. How many miles can you drive? Well, I can drive 3,000 miles for 150 gallons. Okay, we can do this exact same thing again. This is just organization-wise. It says the sides of a rectangle are in a ratio of 4 to 5. We can write the same information instead of writing it as colon notation, fraction notation, word notation. Sometimes it's also in a table, right? So the ratio was of length to width was 4 to 5 in the sides of this rectangle. So if they're saying complete the table of possible whole number side lengths, right? And this is the first few, obviously. Here's times 2. So I'd have to do times 2. I could do times 3, which means over here I do times 3, times 4, times 4, times 5, times 5, right? So these are all equivalent ratios: 4 to 5, 8 to 10, 12 to 15, 16 to 20, 20 to 25. They are all equivalent ratios that will keep the length of the rectangle and the width of the rectangle kind of in the same, they will be compared the same.